So hey everybody, my name is Max Richman. I am a quantitative analyst at Arcadia Power, and the song that you just heard is called SQL by Harry Chapin. You guys might be surprised to know when structured query language was developed 44 years ago, Harry Chapin was instrumentally involved in that, hence the title of his song, SQL. Actually, no, that's not true at all. Harry was not involved with SQL. SQL is a story about, actually, 8 years after he was like in a taxi. He has this taxi story where he was riding along in a taxi and he found an old flame in a taxi. For those of you that don't know what a taxi is, it's like the worst Uber you've ever been in, basically. So he's riding around this taxi, finds this old flame, and then 8 years later, writes a song called The Sequel, which is actually spelled S-E-Q-U-E-L, which is about his getting in another taxi with the same person again, Sue. And Sue is, let's say, someone that he has a lot of feelings for, but doesn't actually get married to. He gets married to somebody called Sandy. And so Sandy, before getting married to Harry Chapin, had like 3 kids with the letter J. They were like, I don't know, Jonathan and Jennifer and whatever. And then they had 2 more kids, bringing it to 5, and all of them had J names as well, like Jeremy and Jebediah and I don't know, something like that. And so it got me thinking that I hope, even though Jared starts with a J, he names all his kids starting with an R. So I'm thinking like Reginald or Rutherford or Rihanna or like some names that like start with R. So this is also a sequel in other ways because I spoke at the first New York Data Conference, New York R Conference back in 2015, where I channeled the spirit of R for everyone. And as you might be able to see from this tiny little Virginia Tech hat here, this is our friend Chen, who also wrote a book called Python for Everyone. And I just love the spirit of those books and this conference of just like, sure, anyone can get started with this. Let's make it easy. So I decided that I would similarly buck the trend and not really talk about R, but talk about SQL. So this is a very gentle intro to SQL. A little bit about me. I'm based here in DC. Yes, I am actually wearing the same exact shirt that I'm wearing in that photo because I am kind of like a hobo, or maybe a hippie or something. I don't know, something along those lines. So I've worn a few hats. I've done GIS in this building for like 5 years for USAID. I founded DataKind in DC, which is a great network also in New York for volunteering your time for do data science for good. And today I work at Arcadia Power doing data analytics. So I'm hoping, unlike Harry Chapin, who tragically died after his sequel in a terrible car accident, that that fate will not become me as I continue beyond the sequel. And I hope that at the next R conference, perhaps like on the moon or on Mars, I can do another photo where hopefully the video is getting like all of this, and then I can have like infinite recursion of like the talks and the person. But anyways, we'll see if we get there. Okay, enough preamble and whatnot. What am I actually going to really talk about in this? I'm talking about nothing, apparently. That's it? No, I guess it'll come back, but I'm going to riff in the meantime. It's a pretty simple agenda. I'm going to talk a little bit about the new renewable energy sector, and then I also made fun of someone yesterday for like their deck dying, and then my deck died. So, and I'm going to talk about some intro level SQL and R characteristics. So imagine like a nice GIF like of a spinning windmill right now. Cool. Does anybody know what 1.5C means? Anyone? 1.5C? It's like a number. You guys know numbers. Does number mean anything? No. All right. Well, if you could imagine lots of GIFs on the screen here flailing around showing how once we reach the global temperature change of 1.5 degrees Celsius, we are screwed, right? So We have unfortunately eclipsed that, as the most recent report from the IPCC announced, meaning that we are well on our way to a lot of terrible effects from climate change. But what can we do about this? It feels like we're kind of powerless. We can actually do quite a bit, at least here in the US, with our own activities and what we do. And we can also do some things with our home electricity usage. So the company that I work for, Arcadia Power, makes it easy for you to basically opt in to make your energy usage green and to save money. So the way that then works is you would sign up on the website and automatically we would find deals for you to save money, connect you to solar projects, use wind to offset what you're using, and whatnot. And we're also hiring like a lot of people in data analytics. So you're interested in kind of combining environmental science with data science, come talk to me. I now have a charming picture of Hadley Wickham up here with the obligatory motivating Hadley Wickham quote, in which he says, "However, in the long run, I highly recommend that you at least learn the basics of SQL. It's a valuable skill for any data scientist." Hadley Wickham. In this next slide, I have a SQL query just sort of laid out in simple format. We have a select statement, which is the beginning of your query. We have an asterisk, which is representing what columns you want to select in your query. In this case, all of them. And we have a from, a bit of syntax that then indicates which table and schema you want your data to come from, and a nice little where clause. So it's really simple when you think about it in your mind. Next, I have another motivating XKCD, because of course every talk needs to be motivated by some XKCD. And in this one, we learned that the mom named, oh, hey, hooray. Great, I'll still detail this because it's still impossible to read it. But basically, we have little Bobby Tables, whose mom named him Robert, single quote, close paren, semicolon, drop, Tables students, which, if you have a Hadley Wickham level of basic knowledge in SQL, you would chuckle at, because basically it results into the entire student table being dropped by the unsuspecting elementary school. So this is why it's important to have some, baseline knowledge of SQL. So let me see if there's anything else worth showing. Oh yeah, here's the thing. So this thing, yeah, hopefully this is somewhat familiar. If not, take a look at it. It's a nice way to query data and do stuff like that. And then finally, oh yeah, here's that nice picture. Oh yes, here is the death spiral. So as you can see, since the dawn of industrialization, we are unfortunately spiraling towards higher temperatures, but you can do something about it. So moving on, the main topic here I'm going to talk about are 7 key areas where you can do something in R and you can do something in SQL. And even though maybe one you're faster than the other, it's kind of worth knowing how you can do both of them. And I'm going to talk about at the end about why you would do one or the other. So at my job, we have, the first step is kind of getting set up with environments and installing databases and software and all of that. So at my work, we use something called Amazon Redshift, which is a data warehouse. There are probably other data warehouses that people use, but what's really nice is it's a columnar data storage with a lot of speed. So it uses an older flavor of Postgres, so it's a little wonky. It doesn't have all the bells and whistles of latest Postgres, but you can join tons of things together pointlessly, and it's really great. So we like using that. We also pull in data with Stitch, which is an API integration service where basically you can plug in your Facebook advertising API, you can plug in your whatever third-party vendor data sources, other groups, and also seamlessly integrate that into Redshift to make just all the data together. It's really fun. And then you can set up your IDEs. So of course RStudio is wonderful on the R side, and then on the IDE side for SQL, there's SQL Workbench and a lot of other great tools for that. And once you're set up with your databases and with your tools. Then it's about bringing the data in. By a show of hands, who's used RODBC before or a variant of that? Oh, great. So good, like half of the room or more, and the other half is probably asleep. But in case you weren't asleep and you really haven't used it, or how many people have used the dbplyr package from the Hadley verse? Okay, about a third of people, a little bit less. Basically, the beauty of these two packages is that you can write SQL directly into R and query the underlying database that it's being pulled from. So in this case, using RODBC, you install a driver on your machine. I intentionally did not do the Java-based one because otherwise you will go down a Java rabbit hole and you will never return. So raise your hand if that's happened to you. All right, yep, wow, that's almost as many people as have used Hadley's database package, which is sad. Okay, so yeah, once you get set up there, you put in all your credentials for your database, you can just like list out your tables, and then you can run whatever queries you want to run. What kind of queries might you want to run? Well, just like in R, you might want to just like know what's in your data. So we have information about just like how many rows are in this data set. So select count from the table and the schema. Or in R, just like tell me how many rows there are. Similarly, you might want to preview some of the data, like how many columns are there, what are the names of them, what kind of data do they have inside of them. You can similarly do that, and you can grab random samples, and you can look at tiny bits of it, both in R and in SQL. Descriptive stats as well. This is where actually sometimes SQL is kind of an advantage over it. So the table command is so simple. It's nice. It's lovely. You can just write table and you can look at some kind of vector, and it's beautiful and it's great. But once you want to start combining a whole bunch of them, like you want to cross 2, 3, 4, 5, 6, 7 variables, then you're like, oh, I got to install packages, or there's probably ways to do it in base R that I'm not familiar with, but these are like, it becomes non-trivial. Whereas in SQL, you just keep writing how many things you want to group things by. So for our utility company, I might want to see how many customers we have across all 50 states with given utility. And I can just say, select the utility name, and then for my next column, have a count of it. So basically an aggregation, count how many there are, and then group it by that first one, utility name, and I get the count by each of the utility names of what I have. And if I want to add also by state, then I add state as a column, and I say group by 1 and 2. And if I want to also add, what specifically, like if a utility is an investor-owned utility, or if it's a small utility, I add that. And you can just keep going and quickly just get nice crosstabs. Now, where R is a little bit nicer is on just like the percentages. So SQL, you have to do some weird stuff where you kind of loop things over things to get your percentages going, but on R, it's nice. You just kind of throw prop table up there. Similarly, you can add rows and columns. Basically, the merge and the join are pretty much the same. You just kind of can dictate what you want to join to what. So you want to append some data, more columns. You can do a left join. If you want to just limit it to the joins, the data between those two columns, you do inner join, that kind of stuff. Let's see. So you can also attach more rows at the bottom. So kind of append things from the bottom. In SQL, that's union. In R, base R, that's R bind. And there are other things within dplyr, of course, that you can use to do a lot of this data manipulation. And let's say you want to create new data. So my previous talk was about R for every survey analysis. And similarly, when you're coding survey data, you're just constantly recreating new coded variables. So you can do that pretty easily in both of these tools as well. Here's where we start to get, I guess, a little bit more advanced, but not so advanced, is subsetting and filtering. In this example, I want to select all the mail customers from the last 2 years that have either wind or solar plans. So I go ahead and type in my query and have a bunch of filters there. Similarly, in base R, you can do that with this or another way of doing it. And you can also use the dplyr package to do some filtering and things like that. Generally, it's quite performant in SQL as well. So then you have subqueries, which is kind of like this idea of nesting things. So you can do a query within a query within a query within a query. And you might do that to, let's say, aggregate something and then join it to something that's like not aggregated and things like that. And similarly, you can use the special character, grid thing, pipe thing, non-pipe thing in R. I'm sure it has a better name that I've forgotten here. So grouping and aggregating is sort of the next big piece here. As I mentioned earlier, you can just keep adding these group bys, group by every column that you have, and you can summarize your data quite quickly. This is similar to what you can do in dplyr. In fact, in dplyr, there's this neat thing called show query, where you can be like, hey, dplyr, what would be the SQL equivalent of what I'm doing here? So if you wrote something there, you could actually see what it looks like on the SQL side and things like that. And then another nifty little, I think, sort of all the things I've been showing you, I just compiled over a month of just working and being like, oh, this is a thing that I did. Oh, this is a thing that I did. Like, it is really this many things, and you can do a lot with data analytics, analysis, and just like aggregation. But another useful one is called a window function in SQL. This is probably one of the more like kind of complicated ones. Basically, just ask your coworker for a copy of their code that's working that has a window function, and then just like plug things in and out until it kind of works for you. But what it allows you to do is, for this example, let's say we have 12 utility statements for customers, and we want to sort them by date, and we want to get the second newest utility statement. So here we have another one of those nested queries, query within a query, where we go ahead and we kind of rank over this statement date, ordering it descending from newest to oldest as the statement rank. So basically every statement gets a rank of 1, 2, 3, 4, 5 all the way to 12, and then from that we select just the one that's the second one. So basically allows you to kind of create a coding and a ranking and a numerical ranking of things based on other columns in your data set. This ends up being pretty useful. And then finally, with all things, it's about reporting. So if you're reading this stuff into R, then you can use ggplot, R Markdown, whatever your favorite ways of reporting things are. Another really useful thing of doing it in SQL is that if, let's say you have Tableau or some other BI tool that you like using, a lot of them can just ingest that SQL directly in. So you can go ahead and just like write your queries up and then take that same query, put it in Tableau, and then you never have to do anything again because the view will just be updated as your database is updated as well. And then finally, of course, the obligatory like Excel outputs as well, always needed for managers, for anyone who doesn't want to live in your R SQL universe. And I have 3 little tabs here that I would encourage you to do in your Excel outputs. Have a summary or high-level takeaways, have your actual raw data in case somebody wants to filter it and play with it, and then actually put your code in there, put your SQL code. It's going to look kind of janky, but it's going to really improve reusability when you have to communicate with your future self 6 months from now, or it's going to really improve that if you have to share and collaborate with colleagues and others, or simply just rerun the analysis the next week when your team member asks you for it. So what are some differences, kind of synthesizing what we've talked about? And I use the word often here, but you could also say sometimes or never. I mean, like, I don't know. Like, you can do all these things and all these things, as Tommy was saying, like, right now, just like, with memory on computers, like, this becomes less of a problem. But, there are huge data sets out there that you maybe want to combine together and do that before you bring it into R. So that's maybe a useful use case for some SQL stuff. Similarly, if you have tons of columns and you want to run like a lot of these frequencies of like 5 or 6, 7 or 10 variables at the same time, I find SQL is pretty useful for that. And then this fourth bullet about sort of ease of understanding is important on the SQL side. Often, if you're like in a product company like me, you work a lot with engineers and product folks who can understand and think and breathe in SQL because it's kind of this lowest common denominator. So even though you might write out the best like prototype version in R of what you want ultimately to be in production, your engineer might not want to look at R. Or if they do, you have to like really explain, oh, this is a weird package, it came from this place, it does this thing, and you have all these dependencies and stuff. So sometimes just modeling what you want to do and handing it over in SQL is a way to kind of interface. Then I'm sure there's many more reasons here. I give them that I'm an R conference that R is better. I'm sorry, there's only 2 bullets, but like in your mind, just like add lots more bullets that I'm forgetting here. But R is often better for modeling, of course, more sophisticated clustering and other like data summarization, all the extensible packages that are there, and then reporting, whether it's through R Markdown or things like that. And then what are some really sweet similarities that bring it together? They're both syntax and code to manipulate tabular data stored in memory. You can do those 7 common tasks that I listed before in both of them pretty easily. They have a lot of built-in functions, data arithmetic, other things that make it useful and easy to work with. You can create new functions within both of them. You can like have as much white space as you want and lots of tabs and new lines and all that stuff to make it as parsimonious or as spaced out as you want. And then there are great IDEs that make it a lot better to transact with and to work with and see the highlighting and all that stuff. And then you can, like with both of them, export to a variety of formats to work with further. So that's it. Thanks a lot.